This is Fan of Astronomy, Episode 9.
10, 9, ignition sequence start. 6, 5, 4, 3, 2, 1, 0. All engine running. Liftoff. We have a liftoff.
Welcome all. This is Fan of Astronomy. Today we got all kinds of neat stuff to talk about, and I realized by going back, Dan, and looking at some of our past episodes, I've messed up that this is episode thing like 3 times.
Did you say the wrong number?
Yeah.
You did?
Or I put the wrong one in, at least once. I know I caught it once, but, yeah. I think it's happened one other time as well. It was just like, oh my God, I got to really start paying attention to what number these episodes are.
In most of my other podcasts, I just mention the title and not the number.
Yeah, I guess that would probably be a good idea, but I don't know. Anyway, my name is Angelo. I am one of the co-hosts of this show, and I am joined this week with my Scandinavian superstar friend, Mr. Don Horning.
Thank you, Angelo, and hello, listeners. I am so excited this time. For all our other episodes, we kind of learned stuff, but for this one, I did not know much about the main belt before we started studying here, so I've learned quite a bit.
Yeah, there's a lot to cover about the main belt. I was shocked at... I knew a lot of it, but when you really start to break down, what do we need to go over just to go over this? It's like, holy crap, there's a bunch of stuff we need to go over first.
Have you found a favorite asteroid?
I've always had a favorite asteroid.
Which one is that?
Ceres.
Oh, how conventional.
Well, it's... Look, I can go out with my telescope in my backyard and find it.
Wow.
You can't do that with any of the other ones.
I think there is some that has an incredibly high albedo, so you can often see them.
Yeah, Pallas, I think you can grab.
Yeah.
And Intradermomeda, or whatever its name is, you can catch that one just because it's so stupid bright. But that's it. Anyway, before we get into the main belt, we need to talk about Patreon.com, don't we?
Yes, patreon.com/astronomy. That's the Patreon for this podcast. If you like this podcast and want to hear more of it, please become a patron at patreon.com/astronomy.
It helps us know that there are people out there not just listening, but taking an active role in wanting to hear more and, throwing your dollars forward. Let's be honest, there's no more active way to let us know that you love it than, cash. It just helps. I don't know why. It speaks a lot more volumes than, hey, great show. It just does.
I'll take hey, great show as well.
So will I, but, hey, great show followed by a couple bucks an episode, absolutely better.
Oh, yeah.
So this week, we look at one of the most misrepresented features of our solar system. Hollywood likes to portray this feature as an area of rubble, almost absolutely impossible to get through. Yet this couldn't be farther from the truth. Today, we're going to talk about the asteroid belt. Referred to as the main belt by the science community, this feature is an amazing formation of asteroids flowing in the exact same orbital tract. This is the strangest thing. It appears to be what we would expect from the early solar system. So why didn't a planet form here instead? Why is it still here? Why doesn't everything just run into each other? What even is an asteroid? What things have we found that we never expected and yet gave us great knowledge of the mysteries of the universe? We will dedicate 2 episodes to the main belt. There's just too much to cover for one episode. Everything from dwarf planets to asteroids with moons. The main belt supports these. The first episode is dedicated to general points of the belt, while next episode, we're going to go over the big 5. These will be all based on diameter, and that would be Ceres, Vesta, Pallas, Hygeia, and Interamnia, or something like that.
Interamnia.
Okay, we'll go with Dan's pronunciation. There is too much info on those 5 to try and put them into this episode. They just deserve their own show. It's not fair to them. Don't worry, this won't be the boring episode, though. We have marvels such as Sylvia, another object named Europa, and much, much more. First, however, we have to understand exactly what an asteroid is. These things are graded much like we do our stars. We separate them by classes. Each class defines the composition of the asteroid. We also have an understanding exactly what the difference between an asteroid, meteor, meteorite, and meteoroid, and a comet is. So,
and you have to remember these things, because there will be a test later.
Well, it does help to know what, the difference between an asteroid and a comet is. Like, an asteroid in general is just a minor planet.
I get the feeling that there could be less terms here because there are many terms.
There are, and a minor planet is just an astronomical object in orbit around the sun. It's not a comet or a planet, and these can range from dwarf planets to small solar system bodies.
And it has no minimum size, right?
I think it's like, no, I don't think it does.
Often in the lists you get like a kilometer. As like we don't care about stuff smaller than 1 kilometer.
Well, that's what
diameter.
We don't care about them, but we do. And these are mostly mineral and rock, by the way. If they're not mineral and rock, they're something else.
Yes.
Such as
comets.
Yeah.
we have dormant comets in the main belt as well. They're not many, but they are there. And comets are mostly made of ice and dust, sort of like the mess you step in when winter starts to leave and the snow is melting and all that dirt from the street. That's kind of the stuff that comets are made of.
What's snow?
Oh, yeah. We have that in the north. It's like white stuff coming down from the sky.
Well, see, the thing is, like, so for those who don't know, I live in western Pennsylvania in, like, the snow belt, where we get, like, lake effect snow, which, if you don't live near the lakes, it's kind of hard to explain, but basically, like, nothing can be going on. The wind can come across the lake in the wrong way, and you can wake up and there be 12 inches of snow on the ground. For some reason this year, I call this the golden age of global warming. We've gotten, like, no snow here.
Okay, we have plenty of snow. We have a similar effect called the Baltic effect, because I live in the north of Sweden, right next to the Baltic Sea. And then you can get over 2 days, you can get 2 meters of snow.
Yeah, I mean, if I was a little further north, because it's weird, like, the further you are away from the lake, the less it hits you. But, like, if you live right on the lake, you can wake up to, go to bed, nothing's on the ground, wake up, there's 2 feet of snow, and you're just like, what? Or there'll be 3 feet of snow, and, you're up on your roof shoveling it off. Like, these things can happen just because the wind changes, so. But just strangely, we've gotten no snow this year. We kind of got off point there. Anyway. Yes. A meteoroid can be made of anything, but it is smaller than 1 meter in diameter.
Yeah, and these are most of the objects in the main belt, but we don't care about them because they're small.
Yeah, I mean, these are the things that, when they come, they're hard to see, one. And two, if for some reason one of these were to enter our atmosphere, no chance of hitting the ground.
No, it just burns up in the air.
Yeah, they burn up in the upper atmosphere, not even the lower atmosphere, just way up there. So, not a big deal. So, that's a meteoroid. So, Dan, what is a meteor?
Well, that's an asteroid or a meteoroid that enters the Earth's atmosphere. And those who burn up and those who don't burn up, they are all meteors. But if they don't burn up and hit the ground, they become meteorites.
Ooh, and those can be comets as well.
Yeah.
That
must be extremely rare.
I would think. So basically, the way you think of a meteorite is it's the leftovers of any stellar object that hits the ground.
Yes.
And a meteor is literally, the difference between a meteor and an asteroid is it just finds its way into our solar system.
Yep.
That's it.
Very simple, wasn't it?
It just hits our atmosphere and bang, all of a sudden it goes from asteroid to meteor. Big difference? I don't know. So, but we have asteroid classes as well, and these are kind of interesting in their own way, because if you know what the class is, you know exactly what these asteroids are made of. And the most common type is what?
The C-type, carbonaceous asteroids. Very dark and hard to see.
I mean, these are things that, just, how do I put this? They're your normal grade dark rock that you would expect to see up in the sky. But strangely, there's so many of these, we have to do a subgrouping on them, and we call this the Tholen classification.
Yeah. And
inside of the Tholen classification, we have normal C-type, which we kind of just went over.
Yeah, and then we have the B-type.
We do, which these are mostly found on the outer belt. They're primitive, but they're volatile rich. These are the true leftovers of the early solar system. Pallas, one of the big five that we talked about earlier, that is the largest of the B-type.
Yeah, maybe we should define outer belt.
Okay, so when we're talking about the inner and outer belt, we're not talking about the Kuiper belt. We're talking about just the main belt. The thing is, it's huge. So there's stuff that's closer to Mars, that would be the inner belt, and then there's stuff that's closer to Jupiter, that's the outer belt. So if I say the words outer belt in this specific term, I am talking about objects closer to Jupiter than Mars. Fair?
Yeah, though some things in the asteroid belt can pass the orbit of Jupiter or within the orbit of Mars, they rarely do. So Mars and Jupiter are kind of the limits of the main belt.
Yes, so F-type. These are rocks that just completely lack the ability to absorb water.
Okay.
Simple enough. And G-type is the complete opposite. It has great water absorption. These are high ultraviolet absorption. These are mostly found of clays and mica. And the one that we know as the largest of these G-type is the giant Ceres, also the dwarf planet Ceres.
Asteroid number 1, the dwarf planet.
Yes, we have another type. Now we're going to go back to the real types, not the subtypes, the main types.
Yeah, the M-types. The M-types are made of nickel iron. They are moderately bright. They are the third most common, and they are planet killers. In what way?
Well, these things, because they are made mostly of metals. I mean, you're going to find nickel, iron, other metals as well, but mostly nickel and iron. These things, when they hit our atmosphere, if they don't explode in the upper atmosphere, they will hit the ground, and these are the things that can destroy planets, or if not destroy the planet, can rewrite the history. Yeah, rewrite. They can get rid of dinosaurs. They can, I mean, like, when these things hit, they're going to hit. So these are the ones that we don't want near us if we can help it.
Yeah, Psyche is the largest one of the M-type asteroids. They can be metal rubble piles, so they normally have very high density, but if they have low density, you can it's still metal, so it's not one object really, it's a lot of small objects kept together by gravity.
Some of these asteroids out there are what's called rubble piles, and basically it's a bunch of little rocks clumped together, but they haven't coalesced. Is that the word I'm looking for?
I think so.
Conjoined.
Such as my favorite, 87 Sylvia.
Yes. And
so
I mean, like, these things have not completely melded with each other. It's just like, it's like taking a pile of ball bearings and standing them on top of each other. There's your rubble pile, especially in the M-type, that's a metal rubble pile. If you take pebbles and do the same thing. They're just held together by the gravity of each other, but they're not truly formed together. And then we have the S-type, and this is the siliceous asteroids. The stony composition and the second most common. These things have a moderate brightness. These are the ones that we find closer to the sun or to Mars. Eunomia is the largest S-type that we know of.
Yep.
So those are the types of asteroids. Those are the differences between asteroids and meteors and all the other crap. And, that's all a bunch of weird, very to-the-point facts that we had to go over just so we can continue on with what we need to talk about. And now we move on to the early belt. And the step to understanding the belt is trying to figure out how it formed. There is enough crap out there to create a small fifth planet, so why didn't it? The quick answer, Jupiter. Its huge gravitational forces stops what's left there from accreting, but it also might have stopped it from joining together in the accretion era as well, because Jupiter kind of took a walk inward. It's hard to say exactly how much mass was lost from the belt in this period. Some absolutely was, however. We call that period the late heavy bombardment.
Yeah, Jupiter, once again, a giant bully in the solar system, and Jupiter holds its way over the main belt. I've seen figures that 99.9% of the main belt has been lost over time, especially during the late heavy bombardment. Jupiter threw stuff inwards, outwards by doing stuff.
Yeah, go ahead.
The mass of the asteroid belt total is only 4% of the moon.
Right.
So we don't have much stuff left.
We really don't. At one time, there was a bunch there, and this was during the accretion disk era. This area, specifically, had its own disk forming, which is the beginning of a planet forming. The formations was beginning, and asteroids were truly beginning to build size. And then Jupiter started wandering inward, and this is from the Nice model that we know this. And it disrupted the belt, sending material everywhere. And the beginning of the
time to be around.
No, not at all. This was the beginning of the late heavy bombardment. And a real quick overview. What exactly was the late heavy bombardment? A quick overview. We don't want to go too deep.
Yeah, heavy bombardment of rocks and comets and crap hitting everything in the solar system. Mostly the stuff in the inner solar system. So the moon, Earth, Theia, Mars.
Yeah, this was what is known as a lunar cataclysm.
Yep.
And it happened a while ago.
Yes, 4.1 to 3.8 billion years ago. So 300 million years of rocks falling from the sky.
That sounds objectively scary as hell. Like, you know, you go out to play in your garden, you're like, okay, I'm going to plant some plants. I'm going to get some squash growing here. You know, I'm going to go ahead and I'm going to make some pasta vajou later. So I need some nice, some parsley and some oregano and stuff like that. And then boom, your garden's gone and probably so are you.
Yeah, then Jupiter throws Ceres' twin on you. So.
Yeah, so this happened during the era of Earth that we know as the Neodymian era and the Erochean era.
Those.
Yeah, so this is like way back when, you know, the Earth became almost molten again.
Yes.
We'll
do a show in the future on the late heavy bombardment. Because it deserves its own show.
Oh, absolutely. But the reason that Jupiter's no longer where it's at, according to the Nice model, is Saturn started to grab it a little bit, and Saturn's gravitational pull started to pull Jupiter back into place to where we know that it is now. Then that brought an end to the late heavy bombardment.
It's like, hey, big guy, come back over here. Stop harassing the little guys.
Yeah, and I mean, truthfully, we don't know how many of Jupiter's moons are just captured things from that era either.
Yeah, I read somewhere recently that Jupiter during this period could have lost like 9 big moons.
Yeah, but it also could have gained a bunch of small ones.
Yeah, I suspect Jupiter is still gaining moons by stealing them from the asteroid belt.
So it's one of those really weird things where it's like, wait a second, you know, we're coming in there. We're going to take some of this stuff. I'm going to swallow some of it. I'm going to leave some of it out there. Oh, and I'm going back out here. So really weird, but we're going to get into Jupiter moons in a few episodes. So
yeah, and this was also the time when Jupiter evicted Planet 9 from the inner solar system. But that's another story, which we'll talk much about later.
I'm sure we will. So once the gas giants moved back into their current places, the belt settled down and truly formed. Then Johann Titius discovered it sitting between Mars and Jupiter in 1766, or should I say predicted that it would exist. Later, Ceres was discovered based on a mathematical equation predicting its existence. We still honor this man by naming an asteroid and a crater on the moon after him. The belt, however, is not the only place we can find asteroids. We find them in many other places. The Kuiper Belt on the edge of the solar system is just one of the places where we can find them, among others. Think of it kind of as a second belt back around Pluto. In fact, Pluto is referred to as a Kuiper Belt object, but more on that at another time. The objects that we have there are mostly not round. Due to the size of these objects, they just can't get to that. How many objects, you ask? Well, let's go with billions of them. Many are pebble size. Only about 7,000 have even received numerical names or designations out there. Yet with the billions of objects, the truth is that most of the belt is made up completely of empty space, with the 4 largest asteroids, Ceres, Pallas, Vesta, and Hygiea, making up 50% of the entire mass found in the belt. These places will one day make a great stationing position for mining colonization. So this was predicted by mathematics by Johann Titius.
It's so stupid, that mathematics. They sort of looked at the distance between the known planets and found a pattern that's not real. It just looked like there was a pattern. And this pattern had a hole in it. And it was approximately where Ceres was. So there should be a planet where Ceres was, or where the asteroid belt is. So, and then they found Ceres, first of the asteroids. Yeah. And they were like, oh, there's the planet.
Yeah, which is nuts. I mean, let's really think about this. I mean, like, you know, stop right here and think about this. This is before computers. This is a guy with a quill, probably, yes. and an ink blot, sitting down doing mathematical equations in his, you know, on paper and saying, hey, there should be planets there. Something should be there. And you're like, you know, I mean, think about that. You try to do some math like that on the back of an envelope, because that's essentially what these guys were doing, and they didn't even have, like, calculators, anything.
But that is one of the errors of this equation, because it is so simplistic.
I know, but the thing is, like, nobody, like, I couldn't come up with it.
And they found the planet. That's like, haha, it worked.
I mean, it's like now we're talking about Planet 9. Like, we haven't found it yet, but mathematics has predicted that it'll be there. And these are supercomputers that came up with this. This came out of a dude's head.
Yeah, that led to the fact that Ceres was considered a planet for a long time, which we'll talk about next time.
It absolutely will. So this belt that he found was found between 2.2 AUs and 3.2 AUs from the sun.
Yeah.
That is the asteroid belt that we know now. So basically it's right between Mars, right between Jupiter. Bam.
Yes.
Get some. And we brought up the Kuiper belt a little bit, so let's give a little thing about that. This is named after Gerard Kuiper.
Yeah, and it's filled with... it's very different from the main belt. For once, it's a lot bigger because it's so much farther out. But it's also a lot more icy objects, and they are bigger than the asteroids of the main belt. Ceres would be like a minor player in the Kuiper belt. So mostly frozen volatiles, and we'll do at least one episode, probably more, on the Kuiper belt. But we have to get past all the planets except Planet 9 before we get there.
Yeah, I mean, asteroids are found there, but you know, you do find a lot of comets out there. That's what the frozen volatiles are. But
sort of the difference between a comet and an asteroid in the Kuiper belt is much less than in the main belt. Sort of anything you can get moving into the inner solar system becomes a comet when it comes from the Kuiper belt.
As long as it forms a tail.
Yes, and they will, because they're mostly water.
Yep. So, I mean, but there are some just rocks out there. So, and those do exist.
In the Kuiper belt, it's so cold that water pretty much turns into rock. Ice is quite hard at those temperatures.
Oh, that sounds dirty.
Dirty ice.
That's not what I meant, but okay. So
I know, I just tried to save you.
So I did mention that our asteroid belt is mostly empty. Basically, Hollywood, they tend to, like, when you're watching a movie or a TV show and they get to the asteroid belt, there's always this ace pilot, you know, zipping through each and every one of these asteroids to try and not crash. But it's really easy to get through them.
Yeah, the Empire Strikes Back is the typical representation.
I mean, there are the average distance between asteroids, and this is an astonishing number. Dan, why don't you give it to them?
600,000 miles, just shy of 1 billion kilometers. And I think this is between 1 kilometer-sized asteroids, or which there are about.
Nope, that's objects.
Okay.
That's all objects. I mean, you have to consider how far out that belt is, and if you put 1 billion objects in there, I mean, that belt is a huge area. You know, yeah. I mean, it's, you know, I can't do the back of the envelope math, but you know, when you're looking at a circle, the further you get out on the circle, the larger the area becomes.
Yeah, so remember that when we get to the Kuiper belt.
Yeah, so it's just so far out there compared to like the Earth that you can just fit all kinds of crap out there, and things will not run into each other at all for the most part, like very infrequently.
Yes, on the scale of the life of the solar system, it happens all the time, just like maybe once every 10 million years or so.
That's the average?
Yes, and we can see these crashes, the sort of effects of these crashes that has happened.
Yeah, we look at the moon.
Yeah, even in the asteroid belt, like we have these collision families of asteroids that they belong together because they were once one asteroid, but it got crashed and crushed.
I mean, you have 1 per 10 million years. So this is not a frequent thing. This is how spaced out things really are out there, and it's just a tad bit absurd.
Yeah, I would mention that the main belt and the Kuiper belt are what you think of when you think of asteroid belts, but asteroids are all over the place in the solar system, and we often care a lot about the near-Earth objects, the asteroids that hang around close to the Earth. They're also the Centaurs and Trojans to the major planets. So asteroids are everywhere, but they are very much concentrated in the main belt and in the Kuiper belt.
Yeah, I mean, when he says near-Earth objects, like last year, I want to say it was, we had one pass between the moon and the Earth.
Yeah, back in 2014, we had one that passed at 1/10 the distance of the moon. So that was fairly close.
That is really close. And these are big ones.
I also wanted to mention a bit like how rare the asteroids are. When we have sent 12 machines, probes, rockets, stuff through the asteroid belt, and none of them has collided with anything. And
Nope.
The probability of a collision is so small that the space agencies just don't care about that. It's not a real risk for them.
Well, I mean, the keyhole that you get to stick, a basketball-sized probe through is 600,000 miles.
Yeah, it's like throwing the basketball in the ocean, and you probably won't hit a boat.
Yeah, it's like, okay, if I stand on the beach of the Pacific Ocean with a basketball, if I hit the water, it's a three-pointer. That's how it is. I mean, it's just like, why would we even consider that to be a problem? I mean, if we send enough junk up there, I'm sure at some point something's going to hit something, but it's so hard to actually hit something out there that you have a harder...
In fact, it's a special event for the space agencies if these probes passing through the main belt actually see an asteroid.
Yeah, without trying to find one.
Yes, it's been noted like, we saw one asteroid at 500,000 miles. It's like amazing.
Yeah, I mean, realistically, as far as getting through there with stuff, it's not a big deal to the point that they spend more time trying to avoid our own crap that we send up around our planet. I mean, like, that's a bigger problem than, getting through the asteroid belt. So it's very, very empty. It's just there is crap out there.
There absolutely is crap out there.
And the neat thing about this crap is we already talked about metals and volatiles and things like that. And in the future, we're going to mine this area.
Oh, yes.
Like, this is just locked up. I mean, we're almost certain there's gold out there. All of our rare earth minerals that we find that, run all these electronics that you're probably listening to this show on, we can find out there. There's just all kinds of crap out there that we can find that we just don't have access to here in the numbers that we're eventually going to need it.
There is a scarcity of a lot of precious stuff on Earth, and that's why sort of there is an economic incentive behind reusing things, because a lot of precious metals are hard to find now because it's been used in electronics and things. And all of these things, or most of these things, are in the asteroid belt. But they are also in, if we look at mining asteroids, the first targets are near-Earth objects because they are near Earth. And they also have interesting stuff. So we expect to be able to get the gold, iridium, silver, osmium, palladium, platinum, iridium, rhodium, ruthenium, and tungsten. We could also get like more basic stuff like iron, cobalt, manganese, nickel, aluminium, or titanium.
That's aluminum for you Americans.
Oh, sorry.
I know everyone else calls it aluminum or whatever it is, and it's like, wait, it's aluminum here.
But the asteroid belt is quite far away compared to the near-Earth objects. So there's actually a discussion on these asteroids, and we have identified 12 asteroids that are all near-Earth objects that will be the first targets for asteroid mining. And that's kind of outside the scope of the main belt, but once we figure this out, and these are smaller rocks, they're closer to the Earth, and once we get the technology down for mining these, then the main belt becomes a more interesting target. It probably involves basing operations on Mars, because Mars is much closer to the main belt.
Or the fact that we do have these giants out there like Ceres.
Yes.
That also can be a fine place to where we can settle down and create whole mining communities that they live on Ceres, and then they go off on their shifts. They fly to the asteroid they're going to work on. They may stay there 6 months to a year, and then they get to fly back and live on their normal area of Ceres for a while, and then they're back out to another asteroid.
But the asteroids are interesting resources in other ways. And now I'm thinking colonization and building spaceship made of asteroids. Let's look at colonization. There are several advantages and disadvantages with living on asteroids. So the low gravity is both. Because the low gravity makes building stuff on asteroids very easy. You don't have to enter a deep gravity well, such as Mars or the Moon or Earth, big stuff. These things have small gravity wells, easy to leave the asteroids. Maybe too easy, I'll get back to that. We have possibly 300,000 asteroids big enough to live on. The interesting chemical composition of them makes them, of course, attractive for mining. We already talked about that. We also have a high surface to volume ratio, which means that it's easy to get to like everything on the asteroid. The Earth is an extremely rich place, but most of the stuff we want on the Earth is trapped in the core. And getting to the Earth core is quite complicated, whereas you could theoretically take all of an asteroid.
Yeah, I like how you said complicated. Like, beyond complicated, dangerous, life-threatening.
Yeah.
Where you go on an asteroid and hey, if I dig a mile into the ground, which, we don't really dig a mile into the ground here even for our materials. But if you were to do that there, you're out the other side.
Yes.
So it's
also some of them are hollow. So, there might be caves you can just start digging inside the asteroids.
Yeah, so
also, except in those rocks that don't absorb water well, we have a lot of water in the asteroids. So you could probably get water for life support from most asteroids.
From most of them. And the nice thing about the mining is the fact that if you want the gold, it's basically on the surface. If you want the aluminum, it's on the surface. So the financial cost of actual mining once you get there, mind you, like it's expensive to get there, but once you get there, the financial cost to do it is almost nil. You need a pick.
Yep.
Go ahead. I was just going to say, you just need a pick. That's really all you need. Like, it's like old school mining in the 1700s, You got a pick. All right, go kick the crap out of that and pull out the stuff we want. And that's pretty much all they got to do. It's not really that difficult.
There's also the possibility then of making asteroids in spaceships, because if you can hollow them out, if they are hollow, you can hollow them out, or they are these rubble piles, you can stabilize them, you can have a huge amount of volume protected from the sun and protected from space. You just have to close up the gaps. So it's not like building a big dome on Mars or something, but here you could use the asteroid itself for protection, and that means that you instantly get a pretty big spaceship from the asteroid. Of course, there are disadvantages as well then. The low gravity, we don't know how we adapt to low gravity, so you probably have to get artificial gravity. And then you could, if you have a big enough asteroid, you could spin it to get artificial gravity, and some of them are spinning pretty fast already. So that creates other problems.
I was going to say, that creates its own problem, because if you spin it in the direct center of the asteroid, you're going to have no gravity. I don't care how fast you spin it, you're not going to have any gravity. So let's say that a quarter kilometer out, we have it spinning at 1G. All right, which is what we have here. And then you go a little bit in, you're no longer spinning at 1G. So you'd almost have to live on the outer edges of it if you're going to try to spin it for your gravity. It's odd to even think that. I mean, I guess it's a possibility theoretically, but the practical application seems like nil to me.
Oh yeah, it could be a thing, but that's it's being considered.
I think it'd be more of a thing with a man-created station where, you always see it in, the Japanese cartoons where you have, all these space stations are just these big round things that spin. Well, that's because, everybody lives at the 1G area, and everything inside of that is just keeping the spin going.
Yeah, but what I'm saying is that this will probably be much easier to create using an asteroid and then hollowing it out and get the same effect, because the material is already there.
I suppose, I don't know. Spinning a huge rock out there and you trying to live inside of the rock at the same time seems like you're just creating a situation where people are going to wander.
You also have the disadvantage that the only asteroid that's around is Ceres. It's the only one that has rounded under its own gravity, making it a dwarf planet. All the other ones are shaped strangely. And most math is built on the asteroid being round, which is being a sphere, which it isn't.
Most of them are not. So, there's a lot of cool stuff that we can do out there with these asteroids.
I have to tell you more disadvantages.
Okay.
The asteroid belt is roughly 2 to 4 times farther from the sun than the Earth. It means that the solar energy is about 4 to 16 times lower.
Yep.
So getting solar energy is harder.
So pack your vitamin E?
Yeah. If it is a very loose rubble pile, then it becomes super hard to use. You have to have rubble of a certain size. Of course, the sun is still dangerous because you don't have an ozone layer. None of them have magnetospheres. Some of them can have magnetic fields, but they are way too weak.
Yeah.
And of course, asteroids are not big enough to retain an atmosphere. So if you want an atmosphere in the asteroid, you have to create the atmosphere inside the asteroid.
Oh, okay. That's not going to be easy because like growing plants in a cave. I mean, I guess moss maybe.
Yeah, I think it can be done, but it's not the most attractive thing for colonization. I wanted to talk a bit about escape velocity from asteroids.
Go ahead, sure.
Because we didn't explain escape velocity.
We did not, and I did promise that it would be in the notes, and when I got writing, I forgot.
It's super hard to leave the Earth. You have to travel really fast, and no matter what size you are, you have to reach a certain speed. And of course that speed is harder to reach if you are big. But when you get to smaller objects, the escape velocity becomes very small. So if you have a 70 kilometer asteroid in diameter, it's like easy. If you start any sort of engine and get any speed, you can leave the asteroid. And once you get down to 5 kilometers, if you have a 5 kilometer sphere, you never get a 5 kilometer sphere. And of course this becomes more complicated with the strange shapes. But in theory, with a 5 kilometer sphere, you can jump off the asteroid. You can just jump about a good jump, and then you leave the asteroid, which is of course super dangerous because then you enter deep space and die.
Okay, I mean, gee, thanks for bringing it down, man. Like there's no hope. Once you jump off, dude, you're dead.
Yeah, but you could, if you could jump from an elevated position, say you have a ladder, and then you push yourself off the ladder straight to the side and not up, you will end up in orbit around the asteroid.
Okay.
Which I find pretty fascinating.
But you're still stuck up there if someone doesn't come get you, and you're gonna die.
Yeah, you could orbit like at 1 meter above the asteroid. Haha.
Man, that would be so cool. So like any Joe Schmo could lob a baseball and create a moon.
Yes.
I mean, because if you throw the baseball, it's gone. You have to lob it.
And I'm gonna talk about a 7 kilometer asteroid that is very special.
I'm sure you will.
Can I talk about Sylvia now?
No.
No.
No, not yet.
Okay.
That's the second half of the show after we come back from this Facebook plug. So just wait a few seconds. Listen to my beautiful wife talk about our Facebook. You know, the place your grandmother goes to look at cat videos. And when we come back, we're going to talk about all kinds of neat things out there, such as the asteroid that Dan is so absolutely enamored with.
87 Sylvia.
Be back in a second.
Hello. Are you enjoying the show so far? I hope you are. Well, if so, I encourage you all to pause the show. Don't worry, we'll wait. Go to facebook.com/fan of astronomy and hit that like button. You'll be one of the first people to know when a new episode comes out. Also, on that page, the guys post articles on the latest news in the astronomy field and outer space in general. You also get to interact with the hosts of our show, Dan and Angelo, there, so please hit that like button on Facebook. Thanks.
Okay, so we're back. So the belt is there. We find many things out there. We have seen moons. We have seen Trojans of other planets. We have near-Earth objects. Then we also see just really cool things, like an asteroid that looks like a cartoon dog bone. That's not a joke. So, Dan, you want to talk, obviously, about 87 Sylvia.
Yes. I want to talk about 87 Sylvia.
Okay, go for it.
I think this is one of the candidates to make into something. 87 Sylvia hangs around at between 3.7, 3.2 AUs. It's huge. It's the 8th biggest. So it didn't make next show, but it's the 8th biggest asteroid. Has about a 300 kilometer diameter. Imagine a place 300 kilometers away And the asteroid is big enough to cover all that area. So it's
Strange.
huge.
The numbers I have on it is 261 kilometers in diameter.
It's not regular shaped, so it depends on which side you look at. It's 384 times 262 times 232, plus minus 10.
So that's the average.
The mean is 286.
Okay, so, and this was discovered May 16th, 1866.
Yes, but we didn't know much about it because the cool stuff we learned in this century.
Like 2005.
Yeah, most of the numbers on the asteroids are not known because it's hard to really discover their exact mass. And we know from other astronomy that if an object has a satellite, it becomes much easier to calculate the mass and other things. And in 2001, they found a moon around Sylvia. And Sylvia is named after Rhea Silvia, the Roman woman, the woman of Roman legend, who was the mother of Romulus and Remus, the founders of Rome. So they, of course, named this satellite Romulus. And Romulus is a 10 kilometer big rock. And it orbits at 1,357 kilometers. It's probably also a rubble pile. So we have this huge rubble pile with a smaller rubble pile around it. Then in 2004, we found another moon closer to Sylvia. And that was, of course, then called Remus. So now it has both Romulus and Remus. There are some other asteroids with moons. Asteroids can have moons, but this is a three-body system, which is quite rare. So 2 moons orbiting. Remus is about 7 kilometers, so it has about that escape velocity that I talked about. And it orbits at 700 kilometers. So imagine a 7 kilometer long star destroyer orbiting 700 kilometers above the surface. That's something you see. That's a spectacular object in the sky.
Yeah, it's really cool.
And with these 3 bodies then, we could make some exact calculations on Sylvia, which makes it one of the most well-known asteroids. There are some amazing pictures. We have actual pictures of all 3 objects. They are, of course, they're pixels. But a lot of artists have worked on Sylvia. So Google 87 Sylvia and look at the pictures. They are quite amazing.
Yeah, Sylvia is a neat one. It is, in 2005 is when we found the second moon, and it's the first asteroid we know to have more than one moon. So, I mean,
I think they found it in 2004 and revealed it in 2005.
According to the wiki page, it says determined in 2005, so I don't know exactly what that means. So they could have found it.
Discovered in August 2004.
Okay, so in 2005 is probably when the data was released and probably confirmed by multiple sources. Yeah, because science, double blind, things like that. I have one I want to talk about.
Please do.
216 Cleopatra.
These names are great.
This was found April 10th, 1880. Its diameter is 217 by 94 kilometers. Okay, and the reason it seems weird is it is a metallic asteroid and it looks like a dog bone.
It looks exactly like a dog bone from a cartoon.
Yep, spot on dog bone from a cartoon. And it has also been one that has since then been determined to have 2 satellites of its own.
Wow.
So, I mean, it's a pretty interesting one and it looks really cool. So that's probably my favorite of the smaller ones, even though this one's not really small.
How do you orbit a dog bone?
I guess in the middle, around the edges. I have no clue.
What's the distance to the moons? I can't see that.
I have no actual information on that in any of the notes I pulled up.
No, they're 3 and 5 kilometers in diameter, the moons. So they are also quite big.
Oh, yeah, they're fairly large. I mean, I guess it could support it. 217 kilometers by 94 kilometers. Like, it absolutely could support
also
that.
all rubble piles.
Yes. So, do you have another one that you want to talk about? Because I have a whole list of them I need to go over.
Go ahead.
Okay, so we have this other one, Ida. Okay, and Ida, it was number 243.
All right.
And this thing is not really big. It's 56 kilometers by 24 kilometers by 21 kilometers. It was discovered September 29th, 1884. But in 1993, we determined that this was the first asteroid that we had found to have a moon. And its moon is called Ida Ildactyl. It's 1.4 kilometers in diameter, and that was discovered, while determined in 1993, it was officially discovered by Double Blind in February 17th of 1994. It is the first confirmed satellite of an asteroid, so pretty neat.
Oh, and it's so close. It's 90 kilometers from...
Oh, yeah. I mean, it can't be much further than that because it wouldn't be there because Ida's not big enough.
Ah, amazing.
Yeah. We have another one here, and this one is called Antiope.
Okay.
And this one is 80 kilometers by 80 kilometers.
Yeah.
I mean, that's a weird number. You're thinking, is that a circle? No. It just kind of is. And it's a double asteroid with nearly 2 equal components. So it's like a rubble pile, but it's only 2 asteroids, and it's stuck together.
Wow.
Yeah, and it was discovered using adaptive optics in the year 2000. That's how they found out that stuff. So very strange and different thing. Like, one side of it we'll say is made of gold. It isn't, trust me. And the other side is made of silver, and they're just kind of stuck together by gravity.
Sweet.
Yeah. You want to talk about Undina, 92?
92 Umbina.
Yeah, Undina. There's some really cool stuff about that. And you brought up collisions earlier, so I thought this was one you'd want to chat about.
Okay, it's a large main belt asteroids at 120 kilometers. What's so special about it?
It was created in one of the largest asteroid-on-asteroid collisions in the past 100 million years.
Oh, it's a member of the Veritas asteroid family.
Uh-huh.
That resulted from collision 8 million years ago.
Yep.
And then they sent me to 490 Veritas for details.
Oh, okay. So you might want to go there then, wouldn't you? How about that?
Yeah, the suspected Veritas collision would have been too far from Jupiter for the fragments to slung into collision course with Earth. 8.2 million years ago. Wow, we found evidence in the seafloor on Earth of an increase in the amount of cosmic dust from this collision for 1.5 million years. It must have been a spectacular collision.
I mean, I would think so. If they're calling it the largest one in 100 million years, it must have been something crazy to see. And it's rather recent.
Yeah, 8 million years ago is nothing in solar system history.
No, I mean, it's just insanely recent, and this was a big asteroid, and it created multiple little asteroids, Veritas, Undina. Undina is bigger than Veritas. I don't know why they call it the Veritas
probably because
collision.
They discovered Veritas first. No, Undina had a lower number as well.
Yeah, Undina was found in 1867, while Veritas was found in 1902.
And the number is the order they detected them in.
Right. So we have another really cool one here that I personally think the name fits it perfectly. And that's 1,566 Icarus. It's a tiny little thing, only 1.4 kilometers. It was found in 1949, but it is the first object from the asteroid belt that we know as a Mercury crosser.
Wow.
Yes, this thing is a belt object, but it occasionally comes in close to the sun like Icarus and gets in between Mercury and the sun and then heads back out to the belt.
What a poetic name.
Yeah, exactly. Icarus is the perfect name for this thing. It's just oh, wow, that's really cool. You're going to burn up because it's only 1.4 kilometers now, and I would assume it loses a little bit every time it gets that close.
Yeah, that's a dangerous place for asteroids. There are no asteroids that orbit entirely within Mercury, but some cross Mercury's orbit and get a close look at the sun.
Yeah, and one of our favorites that we've talked about already on the show. What? Huh? We've never talked about the asteroid belt. Yes, but we have talked about 3,753 Caruthini.
Oh, yeah.
This is just one of those unusual Earth-associated orbits. It kind of just hangs out with us, but it swings out as far as the belt and comes back in.
Pays a visit to the belt.
Yes, and Eureka.
What does Eureka do?
Eureka is the first Mars Trojan that we discovered inside the belt.
Oh.
Oh, wet Trojans in the belt?
It's both the Mars Trojan and inside the belt.
Yes.
Amazing.
Yes, and we have plenty of Jupiter Trojans inside of the belt, such as Achilles, Hector, and Hector's huge. It's 370 kilometers by 195 kilometers.
Oh, that's big.
And it's the largest Jupiter Trojan ever discovered. And there are so many more and so many more asteroids.
We'll talk about the Jupiter Trojans when we get to Jupiter, but they are interesting because they are in, like, there is a Trojan camp and a Greek camp of Trojans for Jupiter. So they're named after the people in the Trojan War.
Right. I mean, we have, just to go over a couple quick ones before we begin to wrap this show up, we have these strange ones at the end that don't have numbers really, but they are part of the belt comparably. First off, let's talk about Apophis, and then we can talk about XR2. These are things that were first ranked on the Torino scale. They're no longer on the Torino scale, but we should probably explain what the Torino scale is, huh, Dan?
The Torino scale is basically the danger scale of how dangerous are asteroids to the Earth.
Yeah,
how likely are they to collide?
Yep.
And what will they do?
Yeah, Apophis itself was originally ranked a 2. Then it became a 4. Like, they thought this thing pretty much was going to hit us. But now it's down to a 0. It doesn't look like it's going to be hitting us anytime soon. XR2 was ranked a 1. That's pretty bad. And then it became a 0. So they no longer think that that's going to hit us. Then we have
not in danger from any asteroid that we know of right now.
Right. We have 2010 2K7 or TK7. This is a third of a kilometer, but it's the first Earth Trojan to be discovered.
Yeah.
So
now we're outside the main belt.
It's just still under the belt, man.
Okay.
As far as the page I have, it's that's just landmark asteroids. You're right. So I mean, so we have all these cool ones, but as far as targets for spacecrafts, because we did talk about this earlier, we know Ceres has already been visited.
Yeah, Ceres is orbited right now by Dawn.
Yes.
Dawn took a tour around Vesta and then it settled in Ceres orbit.
It did. Lutetia was looked at by the Rosetta mission.
Yeah.
Ida by Galileo in 1993. Mathelid.
Yeah.
By Shoemaker. Eros as well. Gaspara is Galileo. Steins was the Rosetta. I'm not putting numbers in these, I'm sorry. Although I probably should. Tatius was Chang's 2.
Yeah.
The Anne Frank. Yes, there's one called Anne Frank. A flyby was done of it by Stardust. Braille had a flyby done by Deep Space One back in 1999. And Itakawa was, it landed and returned dust samples to the Earth by the Hayabusa mission.
Yeah.
Crazy.
Really crazy.
Crazy.
I have 2 more things I want to talk about.
Okay.
First, back in the days when they discovered Ceres, the reason Ceres, maybe this is for next year, but the reason Ceres was no longer considered a planet was that they discovered the other ones. So the order they discovered them, they found number 2, 3, 4. And when they found Vesta, they were like, this is a planet too. And then, but there's another one and another one and another one. So they were like, okay, we have to find a new term. And they coined the term asteroid. So Ceres was degraded from, demoted from a planet to an asteroid. And back in 2006, when Pluto was made a dwarf planet, Ceres was also made a dwarf planet because it was rounded by its own gravity. So Ceres once again became kind of a planet in 2006. We lost Pluto as a planet, but we gained Ceres as a dwarf planet.
And if for some reason the asteroid belt was empty, Ceres would be a planet because of the new definitions for what a planet is.
Yeah, a planet has to clear its orbit, but Ceres is way too small to clear anything.
It truly is.
It sounds huge when you talk about the asteroid belt, but remember that this thing is, there are pictures comparing it to the moon, and the moon is enormous compared to Ceres.
Yeah, I mean, they found the first 4 of these really quickly.
Yes.
And then it took 38 years to find the 5th one, and that was Austria.
Huh.
So, I mean, and that was 117 kilometer in diameter asteroid.
They absolutely did not discover them in order of size, the big ones, but then it's all about the albedo, how much you see of them.
Yeah, and distance away. I mean, it's just naturally going to be harder to see one of these rocks.
Big dark ones at the outer edge, they are hard to discover.
Yeah, you're just not going to see them as quickly as you're going to see something that's by Mars, So the asteroid belt is absolutely super cool. Again, next show we're going to come back. We're going to talk about the Big Five. And, we've taken missions to Vesta and Ceres where we got a lot of information on it. And Pallas is, Pallas is a huge thing. And we have so much stuff to go over just with these Big Five that I think we're going to be able to fill a full show without a problem. But by no means are we covering everything that there is to know about the asteroid belt. And you can always do a little bit of studying yourself. I will not discourage it.
Jupiter has not given up its reign over the asteroid belt. Jupiter keeps the asteroid belt under tight control, and that results in something known as the Kirkwood gaps. Because if you disobey Jupiter and you enter certain areas of the asteroid belt, you get thrown out by Jupiter's gravity. Jupiter has neatly ordered the asteroid belt by resonance gravity. So we have pretty much 6 big gaps in the asteroid belt where you can't be. So if you enter there, Jupiter will throw you out or in. So you obey the order that Jupiter has imposed on the asteroid belt. So I just wanted to mention the Kirkwood gaps. They are holes in the asteroid belt created by Jupiter.
Another thing that I ended up leaving off even after looking at it, I'm like, do we have time to go over this Kirkwood gaps? I mean,
I think it's a cool concept.
It really is. But the thing with Jupiter, when you think of Jupiter and you think of the asteroid belt, the best way to think of it is Jupiter is Kim Jong-un. If you disobey it, you will die. And he doesn't care if it's your brother. You're going to die. So do what he says. Think what he says to think. Because if not, you're going to die.
Because even if you're a Neptune-like planet, you will get evicted to 700 AU if you don't obey Jupiter.
Yeah, Jupiter kind of has its reign on everything in the solar system, short of the sun.
I sort of imagine Saturn as Jupiter's, chilled girlfriend. It's like, be cool, big guy.
Yeah.
Come over here.
Yeah, it's like, come on, look, I'm waving a scarf. Come back over here. Here's a little leg. You sure you don't want to come back here? And Jupiter was like,
water. Come over here.
Maybe I do want to come back over there. Yeah. And then, like any chick, she ran away and he can't even get any closer to her, That was sexist. I'm sorry.
We'll talk more about the resonance gravity with Jupiter when we come to the Galilean moons and how they managed to survive so close to Jupiter.
Yeah, it almost seems odd that it would even be possible, but we'll explain how it happens. And we'll explain how Jupiter has so many Trojans. It's kind of like the opposite of the Kirkwood gaps.
Yes, the Kirkwood collections.
They have a bunch of Trojans as well. But that, again, a future episode. So, if you're listening to us on iTunes, please, I beg you, give us an iTunes review. Hit that subscribe button and say, I want to listen to this show from now on. Because, every couple of weeks I stay up really late and I talk to Dan on the microphone through the Skype call. And, we'd like to know that you guys are listening to every one of them. And the easiest way to do that is hit that subscribe button. Or you can go to YouTube and do what, Dan?
Subscribe to our YouTube channel, Fan of Astronomy. Like and share stuff there.
Absolutely. Hit that like button. Smash that like button. Just boom, 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 boom. Love this show. And, leave us a message there. We actually did get a comment on one of our shows. It just said nice show or good show or something like that. But hey, it was a comment. I enjoyed it. Thank you.
If you're listening to the show on an Android app, or if you want the show to be available on some Android app, let me know and I'll make it available there. There are a lot of Android apps. So sometimes I have to be notified to put stuff there.
But we are available on Google Play if you're listening from an Android device. So you can go there and subscribe as well. It's a little bit harder to find because from what I've found, finding podcasts on Google Play is hard.
Google Play is illegal in my country. They haven't allowed Swedish people to use Google Play yet.
That's the terrorism that, never mind.
What time is it there right now?
It is 3:21 a.m.
Look at what this guy is doing for you guys.
Yeah, I am. Uh-oh, it sounds like we lost Dan.
Oh, I'm here.
Oh, okay. You just walked away from the mic or something. Yeah, I stay up late to do these, so. But, one of us is in the United States, the other one is in Sweden. The timing's not going to be perfect for either of us, no matter when we do it.
But we will still do it for you.
Yes, we will, especially if you go to patreon.com and hit that cash button.
Yes.
If you wanted to find me, you can find me on a lot of different mediums, but the easiest one is to find me on Twitter. That'd be twitter.com/Gonksuo or FOA Angelo. That's both me, and I chat it up to pretty much anyone that sends a tweet to me. I will absolutely respond to it, and you can ask me questions, and I can talk out of my butthole. Dan, how would people find you?
Yeah, you can find me on Twitter as well as Dan Horning. You can also find me on the podcast Fan of History, where I discuss ancient history with Brennan Rankin.
Ooh, another show to listen to. Also, remember the Facebook page. Go there. We post 1 to 2 things every day. We try to do 2, but some days our signals get crossed and we only post 1, but we try to post at least 2 things every day. That way we keep you up to date on what is going on in the science world.
There's so much things to talk about in astronomy. So much stuff happening right now.
Every day something new is going on. So next episode, we're going to go into depth on the Big 5. Ceres, Pallas, Vesta, Hygeia, and Internetmanima.
Yeah, that's right.
Internmia.
Intramnia.
Okay, I don't know how it's said. Either way, the asteroid belt is a distance away, but keep looking up towards the stars and you're going to find something neat and you're going to learn something every time. Thank you for listening, and we'll see you guys in a couple weeks.
What'd you think? Did you enjoy it? Well, if you did, head on over to patreon.com/astronomy and pledge to these guys. For each patron they receive, the more they will be incentivized to improve the show. So help them out so they can help you out and throw them a couple bucks an episode. They will really appreciate it. Thanks.